to talk about the main sequence lifetime of stars. Remember, we talked about the HR diagram, and we mentioned how the stars on the HR diagram are the stars that are living, and pretty much it went like something like this. We saw that these ones were the light stars, and I mentioned that those live a very long time. These are called red dwarfs. Okay, and then these are blue giants. Blue giants. Those live very short. So now we're going to discuss the equation for that. The lifetime of a star on the main sequence is proportional to what? Well, the more mass a star has, the longer it should live, right? Because it just has more mass. So the lifetime of a star should be proportional to its mass. However, if it has a lot of mass, it will also burn up very quickly. Remember, we saw the equation, luminosity is proportional to the mass to the 3.5. If the star is very heavy, it also shines very brightly, which means every second it has more nuclear fusion going on. It's wasting it's burning and it's wasting its hydrogen supply very, very quickly. So it's burning up very quickly also, right? So the lifetime of a star is proportional to how much mass it has divided by the rate at which the star is burning that and using that mass up. So it's m over m to the 3.5. Well, the lifetime of a star therefore is what? M to the negative 2.5, or we can say 1 over m to the 2.5. Okay? It ends up that when we put the mass of the sun into this equation and we do all the calculations and the estimation of the lifespan of our sun, it turns out that our sun will have approximately, for our sun, the lifespan is approximately 10 billion years on the main sequence. Okay, once it ends its hydrogen supply, then it moves off the main sequence, and perhaps it lives about 1 billion more years or so as it is dying. And then after that, it finally dies, and it ends up as a white dwarf star. So the sequence goes something like this. Then it comes back, it becomes a red giant. Then it becomes a yellow giant. Then it goes back and it becomes a super red giant. We can call that red 2. So usually stars like our sun have that 2 cycle, red, yellow, red. Over there, the star gives off most of its mass, and it's left with the core of the star, which compresses and ends up over here as a white dwarf. Okay, so that's the life cycle of our sun. It ends up here as a white dwarf. This whole thing roughly takes about 1 billion years. Okay, this lifespan of our sun is about 10 billion years. Okay. Now we can compare the lifespan of other stars to the sun. What if you have a star that's 10 times heavier? Okay. What would its lifespan be? Well, what we can do now is say the lifespan is proportional to 1 over 10 to the 2.5 because the mass of the sun is 10. And since the lifespan of the sun is 10 billion, we multiply this by 10 billion. Okay, so what do we get? 10 divided by 10 to the 2.5. Okay, and then we multiply this because remember 1 billion is 10 to the power 9. Okay, so a star that's 10 times heavier will live how long? 3.16 times 10 to the 7 years. In terms of million or billion, what is that? Well, that's 31.6 times 10 to the 6th. We can move the decimal place 1 over, and then the power of the 10 will be 10 to the 6th. So we can say now 31 million years. This guy will live 31 million years. That's actually very, very short. Imagine, compared to 10 billion, 31 million years only. So those are the stars roughly about here. They only live 31 million years. After that, they start dying. Do you think it is possible to find intelligent life around one of those stars? 31 million year star that has only a lifespan of 31 million years? Not possible. Okay? It's more probable to find the intelligent life around the sun-like star down here, okay, that could last longer. Okay? How about if a star, let's go even heavier, 10 times, 20 times, 30, 40, let's say 50, okay? So if the mass is 50, its lifespan is 1 over 50 to the power 2.5 times 10 billion. I'm always multiplying it by 10 billion. So 10 divided by 50 to the power 2.5 times 10 to the power 9. Okay? So this one comes out to be 5.66 times 10 to the 5, which is, if you go over, you make this a 10 to the 6th. 0.566 million years. So the ones that are very, very heavy, they're gone in a split second. I mean, it's still long compared to our lifetime, but compared to the lifetime of our sun, it's nothing. 0.566 million years, that's 566,000 years, okay? It lives and it dies very quickly. Okay, how about the red dwarfs? Okay, we saw in the earlier lecture that they can have as low a mass as 8% the mass of the sun. So if we apply this equation to 0.08, we can say 1 over 0.08 to the 2.5 times 10 billion. 10 divided by 0.08 to the power 2.5 times 10 to the power 9. Okay, now you're talking very, very, very long. Now we're talking 5.5 trillion years. So these guys can potentially, if nothing else disturbs and interrupts them, they could potentially live in the trillions of years. Those are the ones way down here. Okay? So basically speaking, the ones that are lighter than the sun by 10-fold or 100-fold, okay, can live about 10 billion, 1,000 billion, 1 trillion. Okay, roughly speaking. So these guys will live about 100 billion, and then maybe these guys will live 1 trillion. Okay? So you're talking, our sun lives 10 billion, down here 100 billion, possibly 1 trillion, and then you go 1 billion, and then you go down to 31 million, and then you go 10 million, 1 million, and so on, okay, as you go up the main sequence. So they live very short lifespans. Now, is it possible to find life around these stars? They live very long, right? The problem is a different problem, okay? The low mass stars do not have enough of the heavier elements, okay? They were born when the universe first began making stars, and they've lasted a long time, but they do not have enough of the heavier elements. We believe that they cannot support life. So intelligent life, we believe, lives more around similar to sun-like stars that live about the same age as the sun, okay? So I hope this helps you in comparing the lifespan of stars and seeing how long they live and analyzing their lifetime. Thank you very much.